Hello Mathies, Gatos here. In this video we're going to continue with the inverse trig functions, and we've already done sine and cosine, so now we're going to do tangent. So same format as my other videos. Let's start with the graph of tan of x. So tan of x is a little different than sine and cosine. Its period is pi, and because tan is the ratio of sine over cos, it has vertical asymptotes. So anytime cosine is equal to 0, tangent is going to have a vertical asymptote. Also, anytime sine is equal to 0, tan will have an x-intercept. So this is what the graph looks like, and you can see my asymptotes and my x-intercepts clearly marked. Now, I know that tangent is a function because if I get a vertical line, so let's say like this. If I take this vertical line and I slide it across, you can see it only touches the function in one spot. So I know it is a function. Now let's look at a horizontal line. So if I were to take a horizontal line and do the same thing, as I slide it along, you can see it fails the horizontal line test. It touches it in many points. So what we need to do is restrict the domain of the original function so that when I do the horizontal line test, it will in fact be an inverse. So I want to restrict it in the simplest way possible. And if we look at the cast rule here, I want to restrict it so I'm getting the most of tangent's graph. I want to see where it's positive and where it's negative. So I know that tangent is positive in quadrants 1 and 2 and negative in quadrants 2 and 4. So I could restrict it in a couple of different ways, but the way that I'm going to restrict it so it's all one fluid piece is from negative pi over 2 to positive pi over 2. Now, not including those values because that would be a vertical asymptote. So if I restrict it in there, I can get where tan is positive and negative in one piece. So I'm going to restrict the domain that way. Now remember with sine, we also restricted sine this way. For sine inverse, we restricted the domain of sine inverse from negative pi over 2 to pi over 2, and we used square brackets to lock it in because it can include those values. Well, tangent has the same restriction, except we're going to use rounded brackets because it cannot include those values because those would be asymptotes restrictions. Okay, so now that we know how to restrict it, let's go ahead and look at how do we sketch the graph of it. So over here I have the table of values for tangent. So these are all the values in radians, and these are all the y values, or the function values. Now the domain of tangent that I am restricting is negative pi over 2 to pi over 2, and that domain will become the range. So negative pi over 2 to pi over 2, rounded brackets because it doesn't include it. Let's now also take the domain of tan x and make it the range. So I'm going to take all these values and make them the range. So x is going to become y. So this is going to be negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. So to help us, just because those are exact values, negative pi over 2 is approximately negative 1.6. Negative 1.6. Negative pi over 4 is approximately negative 0.8. And then same thing over here. So pi over 4 would be 0.8, and pi over 2 would be 1.6. Okay, so now that we've got that, let's now do the range of the function. So the range of the function, because tangent extends infinitely in both directions, was negative infinity to positive infinity. That will, by definition, become the domain of the inverse. So negative infinity to positive infinity. And then I'll take all of my range functions, range values, and those will become my domain of my inverse. So this does not exist. This is negative 1, this is 0, this is 1, and this does not exist. So in the original function, I had vertical asymptotes. In this inverse function, I am now going to have a horizontal asymptote. So my horizontal asymptote is going to occur at positive and negative pi over 2. Okay, let's put all of that together on a graph. So this scale that I'm going up by is 0.5. So let's just label that. So I have 0, 0.5, 1, 1.5, and 2. And then same thing in the other direction. This will just help me graph it a little bit better. Negative 1.5 and negative 2. And then same thing along here. So that's going to be a half and 1 and 2, negative a half, negative 1, negative 1.5, negative 2. So let's first of all draw our horizontal asymptote. So our horizontal asymptote occurs at plus or minus pi over 2. Pi over 2 is about 1.6. So I'll draw in about here, and that is y equals to pi over 2. And then I'll draw in over here at negative 1.6. Another one. So again, I'm just trying to get a rough sketch of what this graph looks like. Okay, so now let's go ahead and do our points. So the first point that exists is negative 1 and negative pi over 4, which is about negative 0.8. So negative 1 and negative 0.8. So negative 1 and negative 0.8 right about there. Okay, and then my next point is 0 and 0. So that stays on there. And then my next point is 1 and 1.8, or sorry, 1 and 0.8 approximately, which is pi over 4. Okay, so I have my 3 points, and I'm going to kind of connect the dots. I'm going to use what I know about the function. So in the top here, since the function kind of curves up, this function will kind of curve out. So maybe something like that. And then passing through this point here, and see how this one here is kind of concave down. When I do the inverse, it'll be kind of like a concave up situation, and then going towards my asymptote. We'll pretend that passed through that point. Okay, so that's just a rough sketch of what the inverse of tangent looks like. Okay, so now that we've done that, we can go ahead and just do some questions. So I'll just put it back to a one-page review display. There we go, so that I can write bigger. Okay, perfect. Okay, so let's do some examples. So in this first one here, I want to find sine of 2 tan inverse of negative 4 pi over 3. So I'm going to use that strategy that I used in my last video. I am going to let theta equal to tan inverse of negative 4 over 3, sorry. Okay, and because it's not an exact value, it's not a nice number on the unit circle. Now, tangent is negative using my cast rule. Tangent is negative in quadrant number 2 and in quadrant number 3. But remember that we are restricting tangent to be from 0 to pi over 2 or negative pi over 2 to 0. So I'm going to work in quadrant number 4. So let's draw our angle in quadrant number 4. Now I know that tangent is opposite over adjacent. So opposite over adjacent. I recognize that as a Pythagorean triplet, 3, 4, 5. Hypotenuse is always positive. Okay, so what I'm going to do over here is I'm going to do sine of 2 theta, because it was 2 times the tan of that. Now, sine of 2 theta I know is a double angle identity, which I can write as 2 sine theta cos theta. So 2 sine of theta. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So remember, when we multiply by 2, I'm just going to put it over a 1, so you remember we only multiply that by the numerator. So I have 2 times negative 4 is negative 8, times 3 is negative 24, over 5 times 5 is 25. So this would be the exact value. Can't go any lower than that. Okay, let's try another one. In this one here, I want to do tan of sine inverse of x. So again, I'm going to use that same strategy. So I'm going to do let theta equal to sine inverse of x. So then I'm really just doing tan of theta. Okay, so let's draw a picture here, sine inverse of x. So x is positive, so I know my ratio is positive, which means that I am in quadrant number 1 for sine. So let's draw a little triangle, and here's theta. Sine is opposite over hypotenuse. And this is the same process. Don't let the fact that there's variables confuse you. Now what I'm going to do is Pythagorean theorem to find out the other side. So Pythagorean theorem would be c squared minus b squared equals a squared. So I really have 1 minus x squared equals a squared. And then I know a is equal to plus or minus the root of 1 minus x squared. Now, because it is in quadrant 1, I know it's positive, so I'm looking here at 1 minus x squared, the root of that. So now I can do what tangent is. So tangent is equal to opposite over adjacent. 1 minus x squared. And that would be my final answer. You can leave it like that. I'm okay with that. If you wanted to rationalize it, I'd be okay with that as well. So rationalizing it would be x root 1 minus x squared all over 1 minus x squared. That would be a good idea if I could simplify something a little bit further by factoring. I can't, so I'm okay with either version. So that is inverse trig relations with tangent. So altogether we've covered inverse, but what about the inverse of converse? We could maybe study that. That could be a question that we look at. Okay, hope this video helps. That's the end of 7.5. You can move on to some textbook questions, and I'll see you for the next video, which is 7.6.